Hi, I'm Edoardo Pedicillo, a PhD candidate at the University of Milan. And today I would like to introduce you the Qibo ecosystem. So Qibo is an open source project that is aimed to have a full stack approach on quantum computing. So as already said in the introduction, from the circuit level to the pulse levels. And it's developed by labs and national quantum hubs that are listed in this slide. This is a scheme of the whole Qibo ecosystem. I mean, don't be afraid, I will not speak about all of these in the slide. Let me just mention that the main core of the Qibo ecosystem is the Qibo API. So the API that we are using to deploy the quantum circuits and to simulate them on classical devices like CPUs, GPUs, or multi-GPUs. But today I would like to speak more about the hardware, the quantum hardwares, in particular the Qibocal, the library that we are developing for calibration, characterization, and verification of quantum devices, and Qibolab, the other library to control the electronics in the lab. So let me jump directly into Qibolab. First of all, just for the context, I want to show you a picture of a quantum lab. This is a superconducting qubit lab that we have at the Technology Innovation Institute in Abu Dhabi. As you can see, there are some cryostats and where the qubits are placed at low temperatures. And then we have some control electronics and other instruments like oscilloscopes, and all together is wired. This is a scheme of the picture that we have seen before. And usually, when we want to perform an experiment in a quantum lab, we want to be able to connect through a host device to the control electronics in order to generate pulses and send them in specific lines, readout, drive, and flux line. And then at the end, collect back the output, that is another pulse. In Qibolab, we want to do it in a platform agnostic way. This means that in our labs, we control several chips with electronics coming from different vendors. And this is thanks to the modularity and the abstraction of Qibolab itself. Mainly, the main concepts of the Qibolab API are the platform and the pulses. A platform consists of a specific chip that is controlled by a specific set of instruments. So, as you can see on my left, the platform class will contain a qubit map, where the qubit class contains all the information about the specific qubit, for example, the readout frequency, the drive frequency, but also the pulse sequence for generating specific native gates. And then we have the instruments. The instrument class contain all the low-level drivers in order to control that specific lab equipment. At the end, the platform class will also have specific methods like connect, disconnect the platform, and execute pulse sequence. The pulse class is just a representation of the physical pulses, so it will have attributes like the frequency, the amplitude, the pulse shape, and so on. And so at the end, in using just Qibolab, we can send easily, we can run easily specific pulse sequences. For example, here we have just to allocate the platform and then create the pulse sequence. In this case, it's just a measurement gate. And then just running the pulse sequence through the platform. So now that we can control a quantum lab, we are trying to calibrate also the quantum chips. usually calibration is important because when we want to try to execute circuits on a quantum device, we cannot do it out of the box, but we have, first of all, perform a specific set of experiments in order to reduce as much as possible the noise and increase the qubit fidelities. I mean, these are some examples of what we call protocols. Usually the protocols are divided in three categories: the one improving the gates and the readouts, the one for benchmarking, so for checking the quality of the calibration, and the optimal control ones that are just, let's say, changing the shape of the pulses to reach specific goals. These are just some of the routines that Qibocal provides. In particular, we have routines for the calibration of single to qubit gates and the readout gate, and for the benchmarking. Also in Qibocal, we are trying to use a modular approach, and for this reason, a protocol is defined by a specific set of data structures and functions. So in this case, for each protocol, we have the parameters that are the inputs parameters of the experiment. Then we pass the parameters and the platform object, that is the platform of the Qibo lab library, into the acquisition function. The acquisition function will generate the sequence for that specific experiment and then will run it directly on hardware. The results are, so the output, are collected in the data, and then the data are used in the fit function. The fit function is just a post-processing. We call it fit just because usually we try to fit the data with a theoretical model. And then we extract from this fitting some parameters that we use to update the platform, so to find a better lab configuration. So usually when we want to, let's say, run a specific calibration experiments, first of all, we have to understand what is the goal of the experiments, and so define the set of experiments that we want to run. For example, here the punch out, the qubit spectroscopy, and the RAPI. Yes. And we have to write in Qibocal a rankard. The rankard is a YAML file collecting informations like which platform we want to run, in which specific qubits we want to run it, but also the list of the experiments with their IDs and their input parameters. Then with a command, QQauto, we are able to run the list of experiments sequentially on that platform and that qubits and update the platform. At the end of the calibration experiments, we are also able to generate a report. A report is a HTML page collecting all the results in plots and tables. Apart from the QQauto that we have already discussed, Qibocal also define other commands that are specific for the different actions of the protocols. So QQacquire will just acquire the data, QQfit will just take the data saved in a folder and post-processing it, and then the report generated the report. This is mainly done because we want to disentangle these actions and maybe run it in different times, in different moments. Sometimes, since we are using Qibocal to calibrate our quantum devices, we realize that for specific tasks, writing a YAML could be cumbersome, and sometimes we want also not to follow a linear set of instructions, but doing some if-else and so on. So for this reason, we are also developing Qibocal as just an API. So this means that to calibrate a chip, we have to run a Python script. And here, what we have just to do is define the set of parameters in a dictionary, define the executor, and then run, in this case, this experiment is the flipping, through the executor. Okay, so just at the end, let me show you what we can do with this, let's say, ecosystem. First of all, just using Qibocal and Qibolab, we can, I mean, we are developing a monitoring tool. So at specific time intervals, we are running some experiments to collect some parameters. In this case, we have the T1, the T2, and the readout fidelity. In a specific case, for example, if the fidelity is too low, we want to trigger a job in order to calibrate the qubits and try to rise the fidelities. Also, just, I mean, another thing that we can do is benchmarking the different drivers. In this case, we have evaluated the execution times for different experiments and for different drivers. And as you can see, the black line is the ideal execution time, that is just the duration of the pulse sequence, and the other ones are the execution times of the different drivers. As you can see, the real time is higher than the ideal time because we have some overheads from the Qibo ecosystem, from the instruments, and the communication between the two. So, at the end, with the whole ecosystem, as said at the beginning, we could try to allocate a circuit with Qibo, like this one. Then, if we have access to a quantum device, we could calibrate it with Qibocal and run the circuit directly on the hardware. Qibolab itself will translate the native gates directly into pulses, as we have already seen, and then just run it and collect the results. So the main point of the whole Qibo ecosystem is the modularity, as we already seen with the protocols in Qibocal, with the platforms in Qibolab. Let me remind you that Qibo is an open source project, so if you want, you are invited to have a look at the documentation, to the website, and also to contribute. Thank you very much.
Thank you very much. Yes, excuse me. First question. Yeah, okay. First, second.
Okay, thank you for the report. And I'm rather curious about what the way you perform the calibration. And I want to know what kind of noise will you consider when performing calibration? And will you consider the physical properties of those noise, for example, crosstalk or leakage, or you just treat them as a black box and perform optimization just like the optimal control? Thank you.
Okay. So, but the first one, what do you mean? How do you perform the calibration? I mean, could be a long answer or a short one. It depends on what do you want to know exactly. I mean,
okay,
if you want, I can.
Okay, I can. Okay, you can explain some details if you wish. Okay.
I mean, what we usually do is, as I already said, just writing the run cards and run it sequentially. And we have protocols that we are using. If we really don't know the properties of the chips, we start with the resonator spectroscopy at high power, low power. So we have the punch-out, qubit spectroscopy, Rabi, Ramsey, and so on. So I don't know if it's enough. And about the noise, I mean, we have specific routines that are measuring the specific source of noises, like leakage and crosstalks. For the moment, we
yeah, that was from the microphone in the room. Okay, so Nekun, you can do the spy camera again.
And
but
I mean, we have specific routines that are trying to measure these sort of noises. And for the moment, I mean, the optimization.
And there are no talks going on right now. This is a break time.
In specific routines.
Good.
For example, I don't know,
Is it fine?
RAM saying that are taking just a particular property.
Okay,
Optimize
perfect.
it, but we don't have,
All right. Okay. So
you just mentioned
you can just
question about related work. So when I think about
leave your Discord thing in this channel, then
what's your main selling point compared to those?
like 10 minutes
we are not
for a
selling
presentation.
anything.
Can well get you
for the
all
moment,
the
this is
sound.
just a small project.
Okay.
We are
So
still
is it fine
developing
if I
so
turn off my
we are
computer
not,
now and
Yes.
maybe
Yeah, you can turn off your screen share and your
also the
camera.
number of chips that we are calibrating,
We'll let you know when it's the time to
in our
present and
qubits is
those
of the
back.
order of 5 to 10, so it's completely different from the orders of Google.
If I
No, I'm not talking
computer.
about Google. I'm talking about university.
Oh,
it's all,
Visited, I think,
or you'd rather me to
okay.
stay here?
7 of the qubit labs in
Uh,
the University of California. So they're very
yeah,
much into both. They have a room
I-
that look exactly
it's
like the picture that you showed
not
us first.
too
except
difficult
using
for
different
you,
technologies.
then
The point is, for the
yes,
middleware
we
that you
prefer
have,
to
use
you to
things
leave your
like, for example,
camera on so you can stay in
What I'd like to
this
know is,
voice.
what is the advantage that
Okay.
they would get by
Okay,
switching
sure.
to your stuff
Yeah.
instead of
Yeah, thank you.
using
Thanks. Thanks.
I mean,
Bye
I
bye.
don't know the.
Yeah.
I mean, I don't know. Really
So
who
I'll
answered
be
this
back
question.
in like.
So I have to. Yeah. Okay.
So I'll be back in
So Arctic was
Yeah,
always
you can come back in an
developed for
hour.
ion technology, and I see
Leave
these
the
examples with superconducting qubits. So that's a
do
difference.
disconnect.
Also, Arctic
Or
provides
just to stay here.
the actual hardware.
you can
whereas I
mute.
believe Qibo
Yeah,
is
you can
just
mute
software,
your
or if we want to call
microphone.
it middleware.
Yep, that's right.
And,
Okay.
And some of these projects
You're good.
also in,
Okay, see
in
ya.
California is like Cubic and Kik. These are also integrated with Qibo. So there's this Qibo SOC integration that integrates the Qibo.
Yes.
Qibo SOC integrates Qibo high level with a Kik FPGA-based control hardware. So I would say at some point they will be integrated or integrable at least.
Okay. Good.
I just visited the lab in Bicocca where they told me
Yeah, indeed.
what's going on.
Yes.
One of the part of the ecosystem.
Yes.
One more questions? Yeah? No? Maybe. Okay. Well, thank you very much again.
Thank you very much.
So we will go to lunch break now, and we will be back at 1:40 p.m. Okay, enjoy.